Hello friends, in this video I am going to teach you about what is guided wavelength, group velocity and phase velocity. These three are the parameters of the waveguide in microwave engineering. First, let's see what is guided wavelength. Guided wavelength is nothing but the amount of distance a wave should travel for covering 2 pi radians of phase shift. Okay, please remember this. The amount of distance a wave should travel for covering 2 pi radians is known as guided wavelength. Here, let's see here, in a waveguide, the distance measured along the axis of the waveguide for the phase shift of 2 pi radians is known as guided wavelength or propagation wavelength inside the guide is called guided wavelength and it is denoted by lambda g. Okay, and one more definition for guided wavelength is the distance traveled by the wave to undergo a phase shift of 2 pi radians is called guided wavelength and it is denoted by lambda g. Simply remember, it is the measure of distance traveled by the microwave inside the waveguide to undergo the phase shift of 2 pi radians, and we have the formula for guided wavelength is in terms of free space wavelength and cutoff wavelength. Here lambda naught is the free space wavelength and lambda c is the cutoff wavelength. That is, the formula is nothing but lambda g is equal to lambda naught by root of 1 minus lambda naught by lambda c whole square, that equal to 2 pi by beta whole square, and this expression is valid for all waveguides. Remember, this expression is valid for every waveguide. This is about the guided wavelength. Now let's see what is phase velocity. Phase velocity is nothing but the amount of velocity which is having the microwave inside the waveguide. That is nothing but, here let's see, for a traveling through a waveguide, the speed with which a particular phase of the wave travels in the propagation direction is defined as phase velocity Vp. Vp is nothing but phase velocity. It is the velocity of the microwave travels in the waveguide. In other words, we can say one more definition like this, that is the rate at which the wave changes its phase in terms of guided wavelength is known as phase velocity. We can represent the phase velocity in terms of guided wavelength also, that is the rate of change of guided wavelength with respect to the time is known as phase velocity, that is Vp is equal to lambda g by unit time. We can write time as in terms of frequency, that is time is equal to 1 by f, that is here 1 by t is equal to f, that is delta g into f equal to, here I simply multiply and divide this term by 2 pi, then I can get the equation like this, that is omega by beta. Vp is equal to omega by beta. This is about the phase velocity and the formula for phase velocity for calculation. Now let's see what is group velocity. Here group velocity is also one of the important parameter of waveguide in microwave engineering. Let's see what is group velocity. When a modulated carrier travels through a waveguide, the modulation envelope travels with a velocity much less than that of carrier. We know the modulated signals travels through the waveguide. Okay, in modulated signal we have two signals, that is one is message signal and the other one is carrier signal. Here message signal and carrier signal is having the different frequencies. For that, these two signals travels with different speeds. That is, here observe, the modulation envelopes travels with much less than that of carrier. That means message signal travels less speed than the carrier signal. Then the velocity of modulated envelope is called group velocity in the air field or hollow waveguide group velocity, which means here we have suppose let's see, it is the modulated signal and this one is envelope and this one is envelope. Envelope is having the low frequency and in between the envelope we have carrier. This is the carrier. Carrier is having high frequency. For that, carrier travels much speed than the envelope. Here the speed of envelope is nothing but group velocity, that is Vg. Vg is nothing but group velocity is equal to d omega by d beta, or in terms of cutoff frequency and guided wavelength is Vg is equal to lambda naught by lambda g into c. And this is about the formulas of for finding the group velocity of waveguide. And these are the three parameters of the waveguide. Those are guided wavelength, phase velocity and group velocity. I hope you understood this topic. Thank you. Thank you for watching this video.